for my session. Thank you so much for introducing me, Professor. And I'm very happy to be the a part of organizing this FDP by our college. Okay, so almost I passed in '98, and almost 24 years back we have passed and passed out, and really it is much happy to because I was the board of studies member for almost 9 years, and used to visit the college frequently. And now actually I plan to come physically, but unfortunately due to the earlier thing, we are not in the position to come over there. But really much happy, and I'm going to present the topic. My in this faculty development program, the synthesis of waste derived electrodes and its applications in energy. 1 minute. How to? It's disturbing now. Please prepare video view. Okay. Anyway. So my topic is synthesis of waste derived electrodes and its applications in bioenergy generation using microbial fuel cell. That is what my topic. Sir, how to remove this? Sundaram sir?
Sir, tell me, sir.
Yeah, it's some something is coming, no? Is it visible or
Visible, sir. Visible.
slide? No disturbance, right?
Sir,
Now, actually, I'm getting some black color. 1 minute. Yeah, now it's okay, right? Okay. So of course, here actually what we have done, instead of spending the time in learning the basic concepts, here of course we have we have taken the case study instead of the literature reviews. Okay, I think you would have previous two programs, eminent people, two or three eminent people. They have, I think they would have completed the fundamental aspects about these. The materials, nanomaterials. Here in yeah. Now is it okay? In this presentation, what I'm going to do is, we have taken we have taken a case study, and actually we have worked and we have synthesized the waste material we have converted the waste material into electrodes, and we have made the application for generation of bioenergy, and especially in microbial fuel cell. So this is what the concept. And now in this here, we are once we have derived the materials or electrodes, right? And we have characterized that electrodes, and then we have applied in the biogeneration in MFC. Okay, so now if you see the introduction part, uh, actually, now of course we know that the energy is really the in need of at the present scenario, the energy is the most important one for all the people. Okay, so of course, and also the usage of energy is tremendously getting increased. That is, there is no other way usage of these things, because due to the growth of various industries, due to the growth of population. Of course, we can say the basic concept is the growth of population, and so due to the growth of population, then we can say there are a lot of sophisticated technologies are available. So due to the growth, there are a huge number of new technologies are introduced. Due to these technologies, the industrialization is also getting increased. So of course, the energy requirement is needed. This is due to the industrialization, and also due to as we have discussed, the increase of the population. And also this is not only in developed countries, also in all the nations, all the even developing nations also. And the demand for the energy sources is predicted to rise over the next 20 years, right? So this plot shows the world energy consumption by energy source. This is right from 1990 to 2040. Of course, it's the thanks to EIA report. And the of course now here which shows the, if you see that, the in the usage of the source, the usage of nuclear energy sources and the renewable energies, and also by using the coal, and also by using the by natural gas we are producing and we are consuming, and also the other gases, other products like petroleum and other liquids. So this is about the so far, then it may be surely it is going to get increased. That is what the schematic representation shows. And the non-renewable energy resources are the no, no, it is getting depleting day by day. Okay, it is getting depleting day by day. So it is very very important for all the countries, okay, by all the countries in the world, to identify the alternative source for fuel. Okay, that is what the people are concentrating. And the of course, if you see the with respect to the as far as the literature survey is concerned, the energy request or the energy requirement for the developing countries as well as the underdeveloping countries are much more compared to the developed countries. Okay, because here, now I think normally the usage of the energy is optimized in the developing countries, in the developed countries. So that is the reason for this. And of course, this is what the demand in the in India. Okay, so this is this shows the just the what about the in the year, when keep by it may be by the electricity, coal, and also the petroleum products and the and natural gas. Okay, this shows the energy demand projection in India. Okay, now of course we have discussed about the energy, and now the ultimate concept is just we can use the waste to wealth. This is what the basic concept be in this presentation. What we can do, we all know that we are having various kind of industries, like we are having. Yes, sir. We are having various kind of industries, like we are having the the pulp and paper industries and the tannery industries and the distillery industries, and there are petroleum industries, cement industries, etc., etc. So there are huge number of various sectors are available. Under these various sectors, various the industries, even we can say the specifically we can say the textile industries. Okay, so all these industries are going to discharge some quantity of waste. So generally we can say this may cause the pollution. Generally we can say this may cause the pollution. Now, if you say what do you mean by pollution, means we can say the introduction of the extraneous matters into the environment. That is what we used to call that as the pollution. Okay. Now here if you say the if you are discussing about the waste, so now as I said that please note that the whatever the quantity of material which are wasting, either this waste may be in liquid form or this waste may be in solid form or it may be in gaseous form, all these consist of some amount of energy. So that is what the most important thing, some amount of energy. So now so this energy should be identified and this energy should be recovered from that waste. So that is the most a very most important aspects. And another thing is generally, and now what we can say, we can say about the usage of the fossil fuel. So of course the usage of fossil fuel has been increased in the recent years. And also the global climate change is caused by the combustion of fuels. That is another thing we have to look into that, which releases the more carbon dioxide into the environment. So as a result of this burning, what will happen? The renewable energy and the carbon neutral bases are substitute to the we can say the fossil source fuels. Okay, of course, which are expected to address the global climate change and also the energy crisis. Okay, so what we can do, so we can associate the energy problem to the other major issues which is confronting by the developing countries. Of course, as we have discussed, the many materials end up wasted. As I told, all the industries or most of the industries, they are releasing the waste, so maybe which may cause the pollution, right? So these materials are not waste. We have to make a note over here is that these materials are not waste because which contains a large amount of energy. So these issues are being addressed by, it is supposed to be addressed by the various technologies which can be used to extract or recover the energy from the waste resources. So demand for energy is not limited to the not only the private residences. Of course, it is industry and all the places, right? So in addition to that, the industrial development is also required. Also required. That is what we have discussed. So the all the energy requirements are met through the efficient energy generation. The traditional energy sources meet the energy needs of home and office. Of course, we can say at present, whatever the energy sources which are available, which may be meet the energy needs. Okay, so what we can say, no, in industries, various energy sources are primarily used. With the traditional energy sources, it is being used regularly. So the prime and another important thing is the primary goals of various energy sources in industries are, of course, to save the energy. So we are supposed to save the energy, right? And the energy demands are gradually increasing as a result of rapid industrialization, and also the of course, again, which in turn cause the pollution to the environment. Okay, and now, of course, here we are supposed to looking into the environmental friendly technology for the long term development. Okay, long term development. So by this way we can use the waste derived material. We can synthesize the electrodes from the waste derived, and we have applied this waste derived material for the generation of electricity in microbial fuel cell. Of course, where we have used the you can use any kind of industrial effluent, but here we have used the tannery effluent. Okay, now, of course, sir, there are a lot of methods. Methods are available. We know about the industrial wastewater treatment. Of course, it may consist of the preliminary treatment, primary treatment, secondary treatment, tertiary treatment. Right. Yes, of course. We know that the industrial wastewater consists of the organic matters and organic and inorganic matters, and which are supposed to be removed before discharging into the environment. Okay, that is we know. And of course, now at present, the people are mostly concentrating on the, as I told, the preliminary method, primary method, secondary method, and tertiary methods. Mostly the present people are mostly now. If you take the industries, normally what they used to do means you can say, for example, you can take the textile industry. So in that, what the people are doing means they are taking the textile industry effluent, and they are adding the calcium chloride and they are adding the alum and other the polyaluminum chloride PAC as electrolytes, and they will what they are doing means they are separating the suspended particles with the high rate, and they are sedimenting the suspended solids. So what will happen due to the density difference? The solid particles are getting moved towards the downwards and getting settled. Okay, now that will be discharged. That will be discharged as the sludge. We know that the name of the solid particles are called as sludge. Now, of course, the supernal liquid may be used as the supernal liquid may be used as the liquid for usage of some various okay, the treated effluent may be used for treatment of various industrial the treated effluent may be used for various industrial purpose. Sometimes it may be used that may be discharged into the river, or that may be discharged into the well, or maybe again it may be recycled. Okay, all such things are happening. So, of course, now this is one case. Another case, if you take the solid particles, Now these solid particle, now the whatever the sludge, solid particles means sludge. So what we can do, we can, by using the landfill method, we are just we are filling somewhere, and we are filling somewhere, and we are drying that particular landfill, drying that particular solid sludge. Now if once the solid sludge are getting dried, then what we will do means, here what we can say, we have converted the liquid effluent into solid particles. Then once it's the solid particles are dried. Now if you are passing the air, now as or not, if due to the natural calamity, sometimes what will happen, either the rain, or due to the rain, or due to the passage of air, what will happen, these the sludge which are dried, it is getting dispersed in the air, or sometimes due to the rain, the whatever the molecules which are dissolved, the chemicals which are present in the particular solid particles are getting dissolved in that particular rainwater, and which may cause the water pollution. And previously the solid particles, the dried solid particles are dispersed in the air, and that may be cause the air pollution. Okay. Now and now of course, now what we have, and also what we can do, sometimes what we can do means, the solid particles can be burned, and that can be the burned, while burning, again, as we have previously discussed, that maybe the sludge may be the dried sludge may be converted into carbon monoxide or carbon dioxide. Now this again will cause the air pollution. So initially we had the liquid effluent. This liquid effluent, we have converted the liquid effluent into solid effluent, thus into the solid waste, again the solid waste into air pollutant. So what we can say means, yeah, and at present this is what the things which we are doing. Now we are converting the liquid, one form of pollutant into another form. So this is what happening at present. So now what we can do, so as we have discussed, whatever the waste, either it may be the solid waste, or it may be the liquid waste, or it may be the gaseous waste, whatever the waste which we are having, okay, which consists of energy, so we can try to trap the energy which is present in that particular waste. Okay. So of course, now what we can do, the biodegradation process have only focused on degradation of the organic pollutants. And now of course here, as we have discussed, the chemical energy may be converted into biomass, and now the excess biomass produced can often clogging of various bioreactors, and also which is going to restrict the mass transfer and also the biodegradation. Okay. So this is specifically discussing about the biodegradation process. So of course, whatever the wastewater which is released from the industries, or day by day it is getting increased, and of course it can be used as the, or can be recognized as the renewable resource for the production of the electricity, fuels and chemicals. Okay. And here, as I told, the one of the important method which is used for the production of electricity or bioenergy is, we can say, the bioelectrochemical system. Okay. It is one of the important emerging technologies in the wastewater treatment, of course, also which in turn which produce the bioenergy. Now generally in these BES, the chemical energy stored in organic matters will be converted into electrical energy. Here please make a note, we are using the waste derived materials to convert this chemical energy into electrical energy. This is what the most important point we have to make a note over here. Of course, what are all the advantages means, maybe it may be the reduced greenhouse gas, and also the reliability and the flexibility, and also the flexibility during the installation, and also the operation, and the we can say the improved environmental quality, etc., etc. So these are all some advantages of the things. Of course, please make a note, whenever you are introducing a new concept, of course, each and every concept will have their own merits and demerits. We have to make a note over, we are supposed to make a note of that also. And of course, here in microbial fuel cell, of course, we are going to use the BES. I told you, know, the BES, that is bioelectrochemical system, in which we are going to use the MFC, microbial fuel cell. Of course, here the one of the important factor is the important part of the microbial fuel cell is is the electrodes. Okay, so microbial fuel cell part, design of reactor and low cost components are offer more perspective of reaping of bioenergy from the industrial effluent. So, of course, if you use the cost-effective materials, surely we'll be able to reduce the MFC setup cost, and also we can yield the high electricity, okay, electricity, and also the possibility of commercialization of MFC with environmental applications. So this is the important point. Okay. Now, if you see the before going to the objective, if you take a microbial fuel cell, surely here here the microorganisms transform substrates into the electricity in the bioelectrochemical system. Of course, this is what the microbial fuel cell, and of course here actually if you say microbes are the liable for substrate oxidation and the electron transfer in microbial fuel cells. Actually, which separates it from the normal. Actually, there is a difference between this normal fuel cell and this microbial fuel cell. Of course, here mostly the microbial actions is going to play a very important role. And the MFC has attracted massive interest among the academic as well as the research people for the sustainable energy production over this decade. Actually, previously, some researchers like Porter, he revealed actually, he was a guy who initiated the research related to the microbial fuel cell. Of course, it was in 1911, that is 1911. And then it was discovered that the inclusion of the electron acceptor might improve the current and power output, and also of course this was the major breakthrough it was made. And the electron mediators were responsible for, here we have to make one point, is the electron mediators were responsible for the initial MFC innovation, and the microorganisms in the form of microbial fuel cell are unable to transport the electrons to the anode directly. The Here directly. So by observing the electrons from the microbes, the mediators can quickly decrease and then discharge the electrons into the anode, reverting to an oxide state. Although mediators can help some bacteria to move electrons more efficiently, and so the more mediators are of course the unstable, and here the limiting of the usage of mediator assisting MFC is also most important. And so what we can say, so if you are going to take the microbial fuel cell, then in this here we are going to take the major objective is as far as the microbial fuel cell, we are going to take the microbial fuel cell, but the another important objective of this presentation is to gain the knowledge about the synthesis of electrodes and improve the bioenergy generation using metal mixed biochar electrodes. Actually, we have we have synthesized the biochar electrodes, and along with some mixing of metals as an anode, and of course which in turn we can minimize the environmental causes. So in addition to that, we are going to know about the synthesis of biochar electrodes using waste coconut shell we use to represent CS, and which can be combined with the metals like silicon, zinc, copper in 20 percentage and 40 percentage mixed proportion. And also to know about the characteristics, just we have conducted the characteristic study, and also to analyze the characteristic study for all the synthesized biocharacteristic electrodes, and to analyze their feasibility for the usage of electrodes. That is most important. See, whenever you are doing some work, whether it is the feasibility or not, we have to check. That is most important. And of course the next one is we are going to apply this uh, synthesized electrode in a microbial fuel cell, which is a dual chamber. Normally it may be in H type, and we are going to perform the experiments, and we have performed the experiments for the bioenergy generation. Of course, here we have used the ternary wastewater as the ternary wastewater as the analyte or electrolyte, we can say. And also, in addition to that, to assess the power generation performance, or to analyze the power generation performance of microbial fuel cell by using 20 percentage and also the 40 percentage biochar metal mixed electrodes. Okay. In addition to that, we are going to analyze the MFC output performance, and also what are all the parameters which are going to analyze, which are going to impact on the, or which are going to make the influence on the power generation. That is like, the various parameters like distance between the electrodes, pH, conductivity, membrane size, and also the thickness of membrane size and membrane thickness on the performance of MFC with respect to the power production are going to we are going to learn. Okay. So, of course, since we are concentrating on the electrodes, let us discuss about the some electrode materials which were previously done by the done by some previous people. So, in this, what they have done was they have used the not only the metal electrodes, they have made attempt of various kind of electrodes. And here the thing is, electrodes, what are all the in this in this presentation, in this particular slides, we are going to learn about what are all the different electrodes which were used by the different kind of electrodes which are used by the previous people, what they have done. So that is what we are going to discuss. So here, of course, this is related to the review of electrodes. So in this, the electrodes like graphite fire brush, okay, this was done by Hayes. Of course, if you say if you say the findings, what we can say means they have produced the good power, and also, of course, they have used it for the domestic power, domestic use domestic industry. They have taken the electrolyte was they have used the domestic wastewater in the microbial fuel cell, and also they have conducted the experiments and they have found the electrodes. But if you say the limitation, of course, the compact reactor design of the MFC was the limitation. So similarly, the graphite electrodes was used by Hosini, and of course, a good power output, and of course, the cathode surface area and everything, or they have analyzed and they have found around 35 milliwatt per meter square. Of course, and here, if you use the graphite, then what we can say, it's a little bit costly. Similarly, the graphite felt anodes, and like, they have used in different different macro structures they have used. So in that, they have used the flat plate and the vertical fin, and also the horizontal fin, right? So of course but they have used these kind of different kind of electrodes, and they have conducted the experiments, and they have found that the vertical fin and horizontal fin anodes remove the organic from waste more efficient than compared to the flat plate. And of course, they have found some considerable amount of power generation in microbial fuel cell. And of course, here the high internal resistance are offered by the during the process. Similarly, there are many studies they have conducted by using the carbon whale fiber, and also, of course, the other type of the electrodes, like they have used the some authors, they have used the carbon felt, and also some people they have used the graphene modified electrode, and also the carbon mesh, and the carbon graphite mixed electrodes, all they have done. Only thing, like, if you say the limitations, if you say the disadvantages of the studies are the of course, the electrode distance, and also the proton fluctuation, and the performance are limited, and the low facilitation for electron transfer, and also the current instability. Okay, so these are all some important demerits. In addition to that, if you the some people also, they have conducted some biochar electrodes. In that, they have used different materials like wood-based biochar and rice-based electrodes, and also the algal biochar and sawdust. These are all the electrodes which were used by the previous people. So in that, like of course, we can, whenever we are using something, some novel materials, surely we have to choose in such a way that whether the feasibility study should be done. Yes. So but if you say the findings of these studies, they have found that of course it may found that when you use the wood-based biochar, okay, they found that they have decreased the total cost of the electrode, and also the carbon footprint, and also the biochar electrode materials provide adequate power output. Yes, so this means that whenever you are this gives the actually gives the clue. So if you use the biochar electrode, then sometimes what we can do means we can get the good adequate power output, but the stability is less. And rice husk electrodes, if you use the rice husk electrodes, and of course they can found that the cost of MFC is a little bit reduced, and of course they accepted the power, but of course the only thing is the less surface area. And similarly alcohol biochar and also the sawdust. Of course, if you take the sawdust, and of course again it is a low cost material, and which could be the economically very friendly microbial fuel system. uh, and another thing is, another very important thing is high internal resistance of MFC. So this is also another important thing we have to make a note over here. So these are all some electrodes, the merits and demerits of the electrodes. So this slide shows the outline of the work, what the presentation shows. So initially the biochar materials were collected, and of course the processing was done by maybe the different processing like drying to remove the moisture content, to remove the carbonization, and to remove the sieving, and also so these are all some different methods which we are normally we are converting the waste materials into the biochar. So after that, once we have done, then immediately we can uh, we can analyze the proximate and ultimate analysis we can perform. We have to perform, and so that we can analyze the components. um, yeah, we can analyze the component. So after that, once we have performed the fabric, once by using the waste, once we have fabricated the electrodes, then we can use, to fabricate the electrodes, just we can have the metal mix electrodes. So that what will happen, this if you are using the pure biochar electrodes, then we have discussed about the demerits of the things. So just to enhance the stability, and also the power production, stability of the power production, and also the conductivity of the electrons. So if you are mixing the metal, then it will be quite easy to get the good power output. So of course we can use the graphite electrode as the control electrode, and of course we have used the silicon. In that, in addition to the coconut shell, we have used the 20% of silicon metals. This is the first type of electrode, and next one is second 40% of silicon. 40% of silicon. This is the second kind of second type, and next one is next one. If you take the zinc, there also we have used the combination of CS and the zinc electrodes, zinc metal we have mixed, and we have synthesized the 20 percentage along with the 40 percentage of CS zinc. And next one is we have mixed the silicon and zinc, we have mixed the copper. So copper and the this one coconut shell. So here also we have mixed the copper and 20 percentage and 40 percentage. Then once the electrodes are synthesized, then we have to apply the synthesized simply once, as I told, immediately we cannot apply the things. Apply the we cannot use we cannot utilize we cannot employ the produce the electrode materials for the generation of power output as the electrodes in microbial fields. So before that we have to make the characterization. So for that we have to make the instrumental analysis like SEM, EDX, and also the FTIR and XRD. So these sort of things we have to perform, and then after that, once we have performed, once we have analyzed, then we will be able to say. And one thing we have to make before and after the activation, that is most important. So we have to activate the things, the electrodes. Then after the activation, there are the procedures are available for the activation of electrodes. So by using that the activation method, we are going to activate, and once the things are getting activated, then we can use it, we can apply for analyzing the performance. So if you are analyzing the MFC performance, of course, then here we are going to study about the conductivity and also the COD removal, then also power output. That is most important, power output and coulombic efficiencies. Here, if you say, sir, what is the dual advantage of or simultaneous advantages of using the MFC is whatever the synthesized material we have derived from the waste, which could be used as the electrodes. First one. Second one, these synthesized, of course, here in addition to that, by using these electrodes, we are going to produce the bioenergy. Second one, third important thing is, in addition to this power generation and the waste minimization, another important concept is that we are treating the tannery industrial effluent. So the effluent treatment is also simultaneously performed. Okay, so these are all the important things which we have incorporated in this case study. So of course, in addition to that, we are going to discuss, and also finally we are going to make the conclusion in our presentation. Okay, right. So this is what the process of the synthesis of the coconut shell electrodes. Here, as previously discussed, the Logan and many people have used the various studies, like as I told, like maybe they have used about the various performance cube and brush type, and different kind of things they have used. I think I have shown the things. Initially, what we are doing means, here, you can take the coconut shell, of course, which is shown. Of course, this coconut shell is the consist of it is a very which consists of more amount of carbon, and another important thing is the when we are taking, of course, this is a waste material. Of course, we know that this can be used for the generation of power in industries. Of course, the people are here again. If you are burning the coconut shell, of course, we know which consists of very good calorific value. So which will give very good what to say, which will give very good energy. But the thing is, when since it consists of the more carbon, when you are burning, then which is going to cause the greenhouse gas, like which is going to discharge the carbon dioxide. In addition to that, there will be a chance for the discharge of the smokes. And also another important thing is, in addition to the smoke, then the particulate matters also gets discharged. So this should be, we can use that coconut shell for a different, for of course, in addition to that particular use. So we can the waste material we can use the use it for the some what to say for specific purpose, right? And here another thing is here the initially we have collected the coconut shell and mixed it with the various metals with the different proportion. That is what we have discussed. Okay, and the we have collected the coconut shell and dried, and of course the dried coconuts were sheaved after being crushed into little pieces of 5 each. So we have to crush, we have to grind it, and we have to sheave to get the 5 each. The of course the material was then the carbonized. That is most important one. We have to carbonize in a muffled furnace with the temperature of 500 degrees Celsius at the 500 degrees Celsius about 1 hour, about 60 minutes. And of course, the resulting carbon powder content, which was combined with the metal compounds like silicon, as we already discussed, the silicon, zinc, or the copper in a ratio of 1 is to 5, 1 is to 5 ratio in order to create the the metal charred metal combined or metal charred metal combined biochar electrodes, right? So which were labeled as the CSSiO2, CSZnO2, Zn.2, Zn 0.2, CS hyphen Cu 0.2. So this means that CS means what we can say means the shell, coconut shell. Okay, so Si 0.2, that means the 0.2 percentage, that means 20 percentage of, not 0.2 percentage, 20 percentage of Si, which was mixed with the 80 percentage of CS. So that is what the representation, and with these electrodes were labeled as CS Si 0.2, CS Zn 0.2, and CS copper 0.2 respectively. And of course, the proposed electrodes, of course, we have just these schematic, the photo shows the proposed electrodes, and the electrodes were filled with the 15 ml of the epoxy resin, which were serves as the adhesive, and of course, the which will give the harden to give the resin. Just that will give the some hardening, and the epoxy resins and the hardener were mixed with the electrodes. Of course, again, it is in the ratio of 2:1. Of course, we can have almost for 1 day, we are supposed to do the curing process under the atmospheric conditions. Under the atmospheric conditions. Similarly, the coconut shell waste mixed metal with the 40% is also 40% is also produced. Of course, again, as I told, the process is repeated. We have to dry the shell, and also we have to sheave the shell, and of course it is after broken into small pieces, and it should be grind. It should be ground, and then after that we are converting that into small pieces of 5 as usual. The procedure are same, and of course it should be carbonized at 500 degrees Celsius for 1 hour, and 1 hour. Then again, as previously done, it should be mixed with the different ratios, and in order to produce the CSASI 0.4, CS Zn 0.4, and also CS copper 0.4. And of course, then again, as usual, the electrodes are mixed with the epoxy resin and hardener, and also the, of course, we have to done the curing process even for the 40 percentage of 40% of these metal mixed electrodes. So this is the this one the what to say the synthesis of electrodes, or processing of carbon cell waste derived electrodes. So this is what the labeling and all other source. Here this is the one side, and that is the just to know the labels, and we are labeling, and to know, to identify the things. And of course, then the next part will be another, a very important point is this material characterization and analysis. here as we have discussed, once the materials are once the electrode materials are synthesized, immediately we cannot use, we are not supposed to use directly, right? So whether it is it is okay, or what are all the different properties, physical and chemical properties of the synthesized electrodes, and also we have to make the proximate ultimate analysis, then we have to characterize these the characterize these materials, and we'll have to obtain. So for that, we have analyzed we are supposed to analyze the physical and chemical properties, and also the proximate and ultimate analysis, and the SIM, and also the FTIR and the XRD. So here, of course, for the material characterization and analysis, the third generation, the 3G, the Malvern the multi-purpose diffractor meter was used for XRD, of course XRD, and the same images with EDX, that is energy dispersive X-ray, were also used to obtain in order to obtain the surface morphology of the metal mixed components of coconut shell electrodes, okay, which we have which we have used. And of course, the another important thing is FTIR. The FTIR study, the FTIR spectroscopy was performed by using a Bruker spectrophotometer. And of course, the surface area and the pore size of the coconut shell base metal electrodes was determined by using the BET method and all the analysis, all the whatever the method which we have produced, which we have analyzed, all these are all based on the what to say, the standard method only we have used. Similarly, if you take the FTIR, of course, here the FTIR, we know that it can be used to analyze the solids, liquid, and gas, as well as to just to analyze the gas, and also to quantify the specific components of unknown combination, right? So, and also it is used to sift the data in collection, processing from an interference pattern to a spectrum. And also it is a very efficient tool for identifying the different types of bonds. Of course, we know that what are the different types of chemical bonds which are available in the synthesized component. Of course, the molecular bonds vibrate at different frequencies depending upon the compositions or components, and also the type of bonds. Of course, we can base all these can be analyzed by using the FTIR principle. Okay. So, and next one, of course, we can say the XRD. Here, if you say the XRD, which can be used to determine the structures, phases, most preferably crystal orientations, that is the most important one, and also the other factors. Like here, if you say the XRD, normally the XRD peaks are produced by the constructive interference of monochromatic beam of X-rays. I think we know the principle of X-rays, and of course the peak intensities are determined by atomic locations within the lattice plans. That is also we know that. So of course, as a result, we can say we'll be able to identify the signature of the periodic atomic configuration in a particular material. And so here in this study, the XRD examination was performed using, as I told, the third generation, the Malvern, the pan-analytical multi-purpose diffractor. So this is what we have used, and of course SEM, we know that we have used the SEM and everything we have discussed, right? And of course the SEM, that is a scanning electron microscope. Here the XRD, of course the energy dispersive X-ray. This is a very popular method now in the recent days, because this EDS detector which can produce more information about a sample when used in the conjunction with the SIM. Okay, so if you are combining the both EDX, of course, SIM and EDX, then it is really good. Yeah, here by focusing electron beam across the surface and also the collecting secondary signals, so the SIM provides the high resolution pictures of materials. Okay, and here of course we know that this technique is the non-destructive and also requires the little no sample preparation, and of course here the surface methodology of the metal mixed compounds, coconut shell electrodes evaluated by using the equipment is called Zeiss Evo 18, and of course we have used the SEM to analyze its characters. And another important thing is, in addition to this FTIR, SEM, EDX, we have also analyzed the CV. That is, we will discuss CV. Of course, it is nothing but the cyclic voltammetry, and of course, this is the method. This is the electrochemical method. Of course, we know that which will be used for measuring the current flow of current through the electrochemical cell when exceeds the of course when exceeds the Nernst equation production. And also it is being performed for the cyclic potential of working electrode, and also the measuring the current which are on the results, and also it is used to investigate the quantitative data about the electrochemical process under various conditions. So this is what we have used, and of course the in addition to that we have also analyzed the MFC performance. That is, we will discuss in the next part. And now, yes. So this is what we have discussed, right? And just we have discussed about the, now we will discuss about the analysis part. And so far, if you have any doubt, you can ask, so that then afterwards we will discuss about the instrumental analysis of biochars. Whenever if you are having any doubt, you can now you can ask, and you can.
Sir, excuse me, sir.
Yeah, yes, ma'am.
Sir, I am Chitra, Biochemistry Department.
Yes,
and is there any procedure for selecting the bacteria for producing
no,
that MSC? So in
yeah,
order to
yeah,
produce the anaerobic condition in that anode, should we select anaerobic bacteria, or aerobic bacteria can also be used?
yeah, yes, ma'am. We can use the aerobic bacteria also, no, but actually we have done only with the aerobic bacteria only. It's
Okay,
all
sir.
depends on which materials which you are going to use. Say, for example, if you are using the tanner effluent, which consists of numerous, not only, since we have taken the real effluent, and
Yes.
one point is which combination of various bacteria. So surely yield will be much high if you take the real effluent. And so here there is no specific factors, there is no need to consider. But the thing is, if
Okay.
you want, you can use the, if you want, you can, what you can do now, you can use the different individual bacterias, you can use for the study, and also you can optimize the bacteria. That is also you can do, since we have taken the real effluent from the tanner industry. So we have analyzed what are all the bacteria are available, and we have there are a few, just let me tell you the bacteria's name in the other in the other part.
Okay, sir.
Yes,
Sir, and
ma'am.
one more question: will the stability of the organic substrate, do they have any impact on the energy generation?
Yeah, sure, ma'am. After probably, once it reaches its after 20 days, it's the generation of the electricity is getting minimized. It's
Yes.
not quickly, but if it is continuous, if it is a continuous study, but of course we have done only the batch mode.
Okay.
If you are keep on using the huge volume of mixers, then there is a possibility of, but it is so tough to have the steady state value. That is what the
Okay.
important demerits of this MFC.
Okay, sir. Thank you, sir.
Yes, ma'am. Thank you. Welcome.
Professor, may
Sir,
give the break for 5 minutes, sir. Professor,
yes, sir. Okay, sir.
participant, please stay on. Join the link. We will back after 5 minutes.
Okay, sir. Thank you.
ஆனா அதுக்கு சவுண்ட் வச்சுதான்
சூரியகாரிதான் தொடப்புல உட்காந்து பரவாயில்ல.
சரி. சூரியகாரி சரியாச்சு. வெரி குட்.
ராய் டான்ஸ்
ரியா ராய் இல்ல ரியா.
dash our bed
மேடு வராது. மேட்னா மேக்னுடைய பாஸ்ட் தான் மேடு. எம்ஏகே மேக்னா உருவாக்குறது, செய்யறது, உற்பத்தி செய்யறது, இதான் வந்து மேக்கு. புரியுதா? ரியா மேட். மேட்னா என்ன? மேட் ஆர் பெட் திஸ் மார்னிங். அதுக்கு மீனிங் தெரிஞ்சதான் மேட்.
Hello, sir.
Sir, yes, please, sir. We continue, sir.
Sir, do you hear my voice?
Okay, sir.
I think now it's okay, right? Shall I continue, sir?
Okay, sir.
Okay. Okay. So I think we have discussed about the what are all the characteristics which we can do, and of course the instrumental analysis for the biochar electrodes as various analysis have performed, and this is what the first one is SIM, that is a scanning electron microscope, and for this the whatever the which shows the 20% of metal mixed biochar electrodes. Of course, the here the this shows the surface methodology of the sample. Yeah, by using the we analyzed by using the SIM, and this shows the schematic representation shows the microstructure of raw silica, and of course the zinc and copper, and also the metal, the mixer, okay, and also the graphene. And of course, as already discussed during the activation, what actually happening means, now we have told, no, initially we are preparing and we are activating the prepared synthesized electrodes. So these during the activation process, a variety of porous surfaces were created, and the surface topology variance between, of course, the raw coconut shell and also the activated carbon. This was revealed by the surface morphology of the sample, that we can say. And of course, the outer surface of the samples, particularly which had a significant porosity. Yes, we know that, which is normally the outer surface of the CS sample is having the porosity. And of course, we can say in SEM photos, of course, for all the samples, which includes the silica, the zinc, copper, and also graphene. Of course, all these, including all these metals, also will have the obvious pores. And of course, we can see the visible here. We can say the visible pores. Here we can say the visible pores in the biochar in biochar electrodes. In all these, we will be able to obtain the visible pores in the biochar electrodes. Of course, after the activation, we will be able to visible that. Of course, which is indicated by the SEM. This is about the 20%. Similarly, for the SEM analysis for 40% metal mixed biochar electrodes also taken, and this shows the schematic representation shows the SIM image for the 40%, and the raw materials, the microstructure of silica, zinc, copper, and graphene. And of course, we know that during the activation stage, so actually what is happening means, during the activation, sometimes what will happen, some sort of whatever the space or pores which are present. 1 minute. Yes. Do you hear my voice?
Yeah, better, sir, compared to the.
Okay, sir. Okay, thank you. So during the activation, what is actually happening? The impurities, whatever the amount which is present in the pores, will get probably some. If it is the carbonous matters or whatever the thing, it will be converted into carbon monoxide or carbon dioxide it gets removed. But here there is no chance for presence of what to say, the water or moisture. Okay. So here during the activation process, the variety of pore surfaces were generated, and as a result, the surface structure of the samples were revealed, of course, by the surface topology, and the samples of external surfaces in particular the usually we can say the all external surfaces, like including metals, which is having the significant porosity. And of course, if you see the CSI.4 or zinc combination or copper combination, and also in addition to the graphene, all will have the significant pores. Of course, we can say we can, from this we'll be able to analyze the yeah, here we'll be able to analyze the pore size, sample size, everything. So this is about the SEM analysis. And of course, the next one is the X-ray energy, of course the EDX for the 20%. Here, all these diagrams will show the EDX spectrum for metals and electrodes. So here, and we know that an X-ray the EDS, that is the energy dispersive spectrophotometer, used for the analysis of these metals. And here, from these results, what we can say means it reveals that the typical and unique lines here of metals like silica, zinc, and also the copper, and also the oxygen, that is the oxygen signal for the mixed metal electrodes, all are shown. And here there is no impurities were found. So from this figure we can say there is no impurities were found, and also this indicates that the presence of metal has been well identified. Yeah, we can say the vertical axis here, the vertical axis shows the number of X-ray counts, while the horizontal axis represents the energy in the unit is keV. So of course there are some values. Let me show the okay, anyway. So yes, yes. So here the peak in the spectrum indicates that all metals like zinc or silica and the copper and also the oxygen have accurately detected. And here what we can say, which shows that these results, from these results, what we can say, the silica, zinc, and also the copper metals along with the oxygen have recognized. Okay, all elemental data in the form of weight and atomic number was investigated by using the, we can say, the EDS spectrum. That is the thing. And of course, this is for the 40% of the composition. EDX for the 40% of the composition. As usual, more or less the same results. And also these results also they explained that the oxygen signal as well as the separate plane of metals in the base here this shows the waste biomass derived carbon electrodes combined with metals, like these metals combined with the metals. And of course, as usual, the horizontal and vertical axis represents the number of course, this is related to the energy, and of course in the X-rays. And here from this we can say, and another important thing what we can say means, it is the samples are very clear, and the spectra shows that all metals and oxygen have been allocated. So this is about the EDX. And of course, next we will discuss about the FTIR. Here, this FTIR also conducted. This is also another important study. This should be analyzed in order to identify the electrochemical behavior on electrodes. This represents the FTIR analysis for the 20% of metal biochar electrodes. And of course, we have given the frequency and functional group identification, everything we have given. And this shows the FTIR spectra for the metal mixed activated carbon from zinc and the silica and carbon samples. And the FTIR spectra shows that the bands for OH are the hydroxyl groups at we can say the hydroxyl groups at the at 3200 to 3500 3500 centimeter. Okay, and the material structure has many carbon bonds, and during the activation at, of course, at 600 degrees Celsius we are doing the activation, the OH and the NH2 groups are stretched out and lost. It remains lost. Of course, we know that another thing is we know that the which consists of the you know the component which are the reason for in brown color, that is the presence of the lignin. So of course we can say the lignin and cellulose components were dehydrated as a result of this. Okay, so since the OH is getting removed, so the dehydration is also getting takes place. So of course the lignin as well as the cellulose components were dehydrated as a result of this. And the of course the CH here we can say at 2900 to 2850, we can say in the range of 2850 to 2900, the CH of CH3 is completely removed from the activated carbon with a peak absorption in the range of around 2800 to 2900. Similarly, the carboxyl, the carbonyl group, okay, that is C double bond O. Here, of course, which are if which are present in the sample, which are samples, maybe it may be in zinc and zinc, silica, and copper is also present. So it may be in the range of 1740 to 1700. Here, of course, here this is related, as we know that this is related to the lignin network, and the nevertheless, because zinc, silica, copper are volatile, and the absence of peak is visible here. The absence of the peak is also visible due to the pyrolysis process. Of course, we all, as we know that we are activating at 60 degrees Celsius, so usually there will be a chance for pyrolysis process also. So the peaks between 1000 to 1200 centimeter inverse, the suggests that the existence of CO stretching is occurring. Okay, the existence of
CO structure is occurring, and
yes, another important thing is, of course, another important thing is while 830 centimeter inverse, which indicates that the presence of silica. Okay, the presence of silica. So the carbonization technique was used to manufacture or used to synthesize the activated carbon from the coconut shell materials, which are the waste materials. Then we can examine by using the of course the things like FTAR and XRT. All these we can analyze. And of course, when the heat, we have to make a note over one point is that when the heat was applied to the sample and the functional groups of spectrum, the raw materials evaporated as volatile molecules. Of course, this is what represented in the data. And also these results indicated that the
activation process was successful, and that the carbon preserves some higher functional groups like C double bond O. Okay, this was found by the this was found by the a previous author. Okay. And besides, the activated carbon has totally transformed into the carbon. Of course, as far as this data is concerned, what we can say means the activated carbon has totally transformed to carbon. Yes. And
Sir, do you hear my voice?
Hello.
Hello, sir.
Tell me, sir.
Sir, it is audible.
Oh, yeah.
Audible,
Okay, ma'am.
sir.
Thank you, ma'am.
Audible.
Okay. Okay. Right. So here, since the activation process are converting the carbon, pure carbon, we can say, without any impurities. Okay. And in addition to that, the here due to the activation, what is actually happening means we can say since we can evident the process of activation and also the hardening of activated carbon. What we can say means the functional group, of course, the adsorption functional group at the adsorption peak is lost. So of course we can say the activation procedure was successful, and like only the few functional groups like CO and of course which is sensitive IR was demonstrated. So of course whatever the results which we have found was satisfied with the literatures. That means that whatever the activities performed, whatever the work we have performed, it was quite acceptable, universally acceptable. Okay, so that means that we have conducted the activation process as per the procedure. Okay. And of course now yeah, this slide shows about the FTIR, that is infra rate. I mean FTIR for 40% of metal mixed biochar electrodes. Here the of course this shows the 40% of the combination of 40% of the individual metals. And here from the results, what we can say, the FTIR deduction of bonds around the direction of bands around around 3433. Of course, it is on the biochar electrode, which reveals that the presence of the hydroxyl group, or we can say the existence of the hydroxyl group. And also between the here we can say around 3300 to 3500 the band values, for these band values, of course, which is for the hydroxyl group. And the biochar electrodes are often high in carbon bonds, which operates as the H and oxygen removing atoms of frequency. Of course, like what we can say, we can say the removal, the removals of components like OH, hydroxyl group, and also NH2 groups are getting removed during the activation. And the components of cellulose and lignin also, as like 20%, the components of cellulose and lignin also were found to be dehydrated in the during the experimental process. And meanwhile, another thing, important thing, is the stretching vibration of the adsorption peak for CH of the CH3 group. It was happen at the 2832 to 3044 44 centimeter square, sorry, centimeter inverse, actually, which is completely removed from the activated carbon. Okay. And due to the stretching, and of course the based on the results what we have obtained during this FTAR analysis of these 40% of metal the 40% of metal mixed biochar electrodes, we can say the carboxyl groups, like C double bond O, of course, which are in the band range of 1776 to around 1770, which are projected to originate from the lignin group, and also in the detected peaks which were extended from around 1200 to around 1100 to 1300, which indicates the presence of silica crystal, okay, which presence of the silica crystal, and also of course which may be also around sorry, which presence of the CO stretching, and around 830 the presence of silica, okay, the silica metal, the presence of silica metal also resulted. So this is about the FTIR. Finally, the FTIR spectra revealed that the activated carbon have completely switched to carbon. Okay, they completely switched to carbon. And another important thing is here, a major of the most of the functional group adsorption peak which are lost during the activation method, and due to the hardening and activation process. And the functional groups of raw materials which are vaporizes as volatile materials when you are applying the heat, so the, of course, now what we can say means we can confirm that the as like 20% the activation procedure was successful, and a few functional groups like CO and also the CO and other things like the sensitive IR are demonstrated. So this is about the FTIR analysis. Okay. Next, another important analysis is X-ray diffraction. Of course, the schematic representation shows the X-ray diffraction spectrum for the activated carbon metal coupled with the coconut shell comprising of which consisting of silica and zinc and copper. And here, from the experimental results or from the experimental analysis, the peak diffractions of silica, zinc, and the copper, of course, which were recorded at the angle of 28.5 degree, and the another for zinc it is for 10, and for copper it is almost around 14.5, we can see. So from these results reveals that metals can be discovered in activated carbon electrodes. So that means that whenever you are doing the activation process, so will be when you are mixing, then we can say that we can analyze that or we can say that the metals also present, and the remaining the minor peaks, the minor peaks observed at diffraction angles like 48. Okay, so here you can see that 48, all these peaks, 48 and 24, 24, and also the around 32. All these the indicates of some presence of ores, quartz, and also some sort of minerals, So this is what the the presence of the XRD analysis of 20%. Similarly, the XRD for 40% of metal mixed biochar electrodes are shown in figure. So here, which represents the XRD powder, of course, this XRD spectrum. The results, the peaks are observed at the angle of the diffraction angles of 27.5 degrees Celsius. Here we can say the 27.5 degrees Celsius and the 27.5, 10 degrees Celsius, and the 24. All these peaks, which represents the metal contains of course, with the presence of the metals, the activated carbon electrodes, which includes which consists of the CS Si 0.4, and also that is the presence of zinc, and the mixture of the presence of copper, that is a combination of CSCU, CS copper, combination of CS zinc, and combination of CS Si, of course, which is based on the results. And also from the results we can say the metals also present in the activated carbon electrodes, and the wide diffractions were observed in both carbon samples, which indicates that the amorphous structure here, another important thing is here, which indicates that the amorphous structures was loaded with carbon rings, okay, and an adsorption gap was formed. This is the important thing over here. And of course, here the mine here also, like the remaining peaks, the whatever the things which are present, and the remaining peaks indicates the presence of the silica and other things. And of course, the most important, the silica is also present. So this is about the XRD. Yes. So just I have started to discuss about the cyclic voltammetry. This is the most important one, and here this represents the cyclic voltammetry for the 20% and 40% of the electrodes. Okay, here of course the electrochemical behavior of the electrode materials, which can be evaluated by using the cyclo voltammetric method. And we all know that as a function of activated carbon loading, it shows the considerable changes in the electron discharge and also in the energy output, of course, which is during the forward and the backward scanning procedures, there are no visible OR peaks. That means the oxidation reduction peaks. Okay, as whatever the results which we got, we have shown in this figure. And the metal combined coconut seed electrodes provides a lot of power when compared to the other electrodes. Just you can compare, and you can also you can see it is in the with the control with the graphite electrodes. And now here, of course, what we can say means, what we can conclude from this CV, as a result, changed properties than the other electrodes. And the maximum, of course, during the experimental study, the maximum currents of 0.29 microamps and the 0.29, 0.48, etc., during, and also the 1.9 and the 1.9 milliamps are observed during the onward scanning process, and also during the backward scanning process 0.39 and up to 2.7 was observed. And of course, the comparable tendency of CV is explored using the electrochemical oxidation with the changing of carbon mesh. Yes, this is also another point we have to make over here. That means the comparable tendency of CV, which can be explored by using the electrochemical oxidation with the changing of carbon mesh. So of course, based on the literature, when you are increasing the activated carbon, loading, and and also which enhances the anode power, so so what we can say, more inactivated carbon means we can say that the electrochemically activity. So of course, here we can say the microbial fuel cell performance is improved by when you are using this kind of electrode, where the major electrode surface change, we can change the micro, as like whatever we have discussed, we can change and we can enhance the performance of the microbial fuel cell. Same kind of things. Similarly, during the electron discharge and also the bioenergy production, the function of the activated carbon loading generally varies greatly with CV process. Of course, when you are comparing with the 40% metal mixed bioswar electrodes. And here one thing we can say, the modified biochar electrodes provided the maximum output when compared with the the control electrodes, that is the graphene electrodes. So what we can say as a result, the upgraded biochar electrodes performed better in terms of the electron transport when you compare with the control electrodes. And also the modified biochar electrodes produce the maximum current, that means almost around 0.32 milliamps and 0.52 milliamps and up to 2.3 milliamps during the forward scanning, and also during the backward scanning almost up to uh, up to 3 millivolts with the scanning rate of 50 millivolts. And of course the carbon mesh was modified using the electrochemical oxidation process, and of course the same CV trend was found. When you are comparing with the, but whenever we are doing the experiment, we are supposed, as we already discussed, we are supposed to compare with the available literature data also. So when you are comparing the available literature data, which was really accepted by the results were accepted with the literature evidence. Okay. And so as a result, what we can say, the metal electrochemical activity was discovered, which was getting improved whenever you are mixing whenever you are mixing the carbon CS and also along with the metals. So these type of electrode modification, which also we can say, which enhance the performance of MFC. So this is what about the CV activity. Okay, CV analysis. Okay, now come to the main. So far we have analyzed the characteristics of electrodes, whatever the electrodes which we have what to say, synthesized, and we have characterized, and also we have analyzed, we have performed various kind of analysis, and SEM, FTIR, EDX, etc., CV. And now we are going to for the main picture. Simply what we can say means the whatever the metals which we have discussed, which we have synthesized, now we are going to use for the microbial construction. As I already told, the microbial fuels in microbial, what is the mechanism behind the microbial fuel cell means the microorganisms which are present in the electrolyte, that is, which are the electrolyte means which are normally we use to take the cannery effluent. Microorganisms which are present in the electrolytes will transform the substrates into the bioelectricity in a bioelectrochemical mechanism. Normally, the equipment is called, normally whatever the equipment we used to call that, normally we used to call that as the MFC, microbial fuel cell. So so this is and normally another important point here we have to make a note over here is the electron mediators were responsible for initial microbial fuel cell innovation, as we already discussed. And of course by observing electron, the mechanism in addition to the points related to the mechanism, by observing electrons from the microbes, the mediators can quickly decrease, then discharge the electrons to the anode, and reverting to it oxidized state. And also the mediators can help some bacteria to move electrons to more efficiently and more efficiently. And also here the particular bacteria can transmit electrons directly to the electrode without using the mediators. But here the sometimes some studies also over some studies also there related to the mediatorless MFC. And of course normally the electrochemically active bacteria are normally the Chivinella, and also the Geobacter and Rhodophyrex. So these are all some microorganisms normally the people are using. And here of course if you take the research, the electrochemically active bacteria itself will have a very big what to say, the research area. So numerous studies have been conducted in optimizing these parameters. And what we can say, when you are comparing the traditional bioenergy production methods, the bioelectrochemical method have many advantages. As we already discussed, it is very simple. Okay, and also this is the MFC. For example, if you take the MFC, it is the non-polluting technology. Another one, and another important thing is whatever the carbon dioxide which are the waste, which is normally the gas which is released during the progress. Okay, and of course here the whatever the release of carbon dioxide is less. And also what we can say means MFC produce the minimum quantity of we can say minimum quantity of sludge. Simply what we can say means there is no production of secondary sludge. That is, we have to make a note over here. There is no production of secondary sludge. So minimum quantity of secondary sludge only produced. And also, of course, the operation procedure is also very mild, very quiet. Okay, and so MFC can be employed in low temperature and also the low strength wastewaters, and also the application of the MFC are much high, especially in wastewater treatment and also the bioenergy generation and biosensors and also the biohydrogen production, desalination, and all this. As we already discussed, normally what is happening means here at the anode, we of course which consists of normally single we can say the dual chamber, single chamber MFC is also available. Single chamber means only they will have a single tank in which both anode and cathode will be there, and they normally they used to do the they used to do the work. And the dual chamber, which consists of a H type of model, which of course if you see which consists of the both anode, cathode, and also the normally we can fabricate by using the acrylic glass. Normally, if you take if you take the anodic, the picture shows the anodic chamber as well as the cathodic chamber, and we have purchased the electrode. We have purchased the membrane, which is separated by the membrane, which is Nafion membrane, Mirari Chennai, and of course the capacity is 500 ml capacity. And here, if you we can take the choke the effluent by using the tanner effluent. And another thing is here what we can say, if you say the reactions, here, as I told, it may be consist of the anodic chamber and cathodic chamber. Here what we can say, at the anodic chamber, the carbohydrates reacts with the water, which will release the electrons. At the cathode, oxygen will react. Here the oxygen will react, I think we can see here, the oxygen will react with the electrons, and which will combine the water. So of course here we are sending the wastewater, and here the microorganisms also present, anode, and the electrons will be produced. And here also here the some due to the here the oxygen also we can supply. If you want, we can supply, or sometimes of course we know that we can conduct the experiment by aerobic condition or anaerobic conditions. We know that the aerobic conditions means if it is the presence of air, sometimes we can conduct the anaerobic conditions also. But it's all depends on which type of microorganisms which we are taking. If it is the anaerobic bacteria, then we are supposed to conduct the reactions only at the anaerobic conditions. Okay, so this is what about the things. And here, if you say the normally the components of the microbial fuel cell are anode, cathode, and also the membrane. These are all the very important physical components of the microbial fuel cell. And what we can say means, which can be the cost of the microbial fuel cell can be reduced by the effective electrode materials, as we have discussed, the biochar. If you use the waste derived material, But here what we can do, in addition to this, another important factor we are supposed to consider is the reactor design is also one of the important or significant factor which is going to make the influence on the MFC cost. So the most suitable materials for MFC, or we can investigate, and we can, in order to produce the most cost effective and also the effective power production. So previously, as I already discussed about the various electrode materials, overall they have used, what are the different kind of metals they have used, already we have discussed. Okay, and of course here this is about the procedure, what is actually happening in the procedures. Normally all these, the potassium ferrichloride and the buffer solutions are probably these things are used to attain the steady power, and also the, of course, not we have conducted at the room temperature. And of course here as I told, still the experiments were repeated till the 20, once it reaches the 20 micron world, and almost it took almost 15 to 20 days. Then after that this should be replaced by using the new thing, and again it should be it should get operated. So here the as I told, the another important thing is, a very important factor here is the design of microbial fuel cell reactor. Here, as I told, it is one of the important factors which are going to make the MFC's performance, one of the important factor which is going to influence on MFC's performance is reactor design. And of course we can have various kind of capacities. Probably the previous researchers used various capacities, and normally, as I told, whether you're going to use the single compartment or double compartment, but mostly the double compartment chambers were frequently used for, but only with the small scale. That is most important point. And of course as I told, the cathode and anode compartments can be separated by a membrane. Of course, where what is actually happening means, which allows the protons to flow through the cathode. And of course the during the operations, the cathodic electrolyte which is from cathodic part to the anodic part, and of course the disallowed the membrane, and also a salt bridge is used. Salt bridge is also used, of course, which is also with the low cost. And of course we can use the heated glass tubes, and you can spin this into U shape, and also you can make some Har and salt solutions, and you can make the salt bridge, and you can use by using the proton exchange membrane, we can say the PE membrane, and you can make the or you can prepare the MFC. And of course we know that the salt bridge normally in used in MFC, it may be connecting the two glass tubes with the salt bridge. Of course, whenever you are whenever you are using this, then it is very it is much easy to get the readings. And also, in addition to that, mostly, as I told, H type of MFC, and also mostly the batch type. Batch type is mostly wide used, but we have used only the batch type. And of course normally the people are using the continuous type of things also. Though the various kind of reactor designs are used, here we have used only the what we can say means the two things means the H type dual chamber, the MFC was used. And now let us discuss about what are all the important factors which are going to make the we supposed to use the decrease in the construction and the cost related, which is supposed to reduce the cost as well as the operation cost and also the maintenance cost. All these are all most important factors. And of course, in addition to that, there are some factors also in addition to the power production in OCV and also CCV mode and pH, and also the polarization of curve and the conductivity, COD, Coulomb efficiency, etc., etc. There are some more factors also important, like architectural factors, as I told, the reactor design, and also the operating factors. All these are all operating factors, like the pH, temperature, the external resistance, substrate type, and also the concentration of feed rating, and the conductivity of the feed. Everything is going to make the influence on the things. And also, as I told, the external resistance, in addition to the substrate type, and also the loading rate, and also the the biological factors. That is what ma'am also asked. Now, if you use the, actually, when you are using the different kind of the microorganisms, what actually happen means, which will grow the which will grow the biofilm on the surface of the electrodes. So the biofilm thickness is going to play a very, very important role. So depending upon the capacity of the individuals microorganism on performance of growing the biofilm, the microorganisms will be selected. So that is also